Welcome to the project demonstration of power monitoring using Raspberry Pi and machine learning along with load identification system and classification. So here we are continuously monitoring the two loads independently with help of two independent current transformers, and based on the signals from this current transformers, our Raspberry Pi will predict whether the load is a low or medium or high or else no load. So these predictions will be done with help of linear regression algorithm in machine learning concepts, and here we are using Arduino Uno board just in order to provide the analog to serial conversion purpose. Means the system is getting the analog voltage output from this current transformers. These two are the current transformers which are used to measure the 1 amps of current maximum, that is around 230 watts of power can be measured by these two current transformers. The output is AC signal, so we need to convert that AC to DC. For that we are using this potential divider circuits which has the potential divider resistors along with AC to DC converter DB107 IC and one filter. So after these steps the voltage will be stepped down to the below 5 volts, as the operating voltage of this Arduino Uno is a 5 volts. So once the system is getting the voltage from this one, then directly it will forward the same voltage values of the output of this current transformers in terms of DC to the Pi 0 to W. So there we are going to predict the load status in 4 ways. One is the no load, and the next is the low load, and the next is the medium, and next is the high load. So this is the main process, and the output is displaying on the 16:2 LCD screen. We have interfaced that at pin number 17, 27, 22, 9, 10, 11 pins of our Pi 0 to W. So here we interface to the Pi 0 double directly, and the serial data is getting from the transmitter pin of the Uno board to the receiver pin of our Pi 0 to W, and A0 A1 is connected to this potential divider circuits. So coming to the total components, we are providing 230 volts AC input to this regulated power supply board, which will take 230 volts AC input and provide us the 5 volts DC output. That is the operating voltage to our Arduino Uno as well as to the Raspberry Pi 0 to W, and parallelly 230 volts is input to these two load sections through these CTs. So current transformers are connected in series to the loads, so that we will get the same current which was consumed by the loads will be applied on this current transformers, and the output is input to this potential divider circuits independently. Separately we are continuously monitoring that, and using the switches we can isolate the loads to the CTs. Now let us see the demonstration. So just on the power supply to this. So wait till the Raspberry Pi boot in successfully. Once the Raspberry Pi boot in successfully, then it will display the welcome message on the LCD screen directly. So it will take around 30 seconds maximum for boot in, as it has the 32 GB memory card. Here we can see that the red color is the 32 GB memory card which has the operating system along with Python code. Right, welcome to the project displayed on the LCD screen. So as of now, no load message is displaying on the LCD screen. We can see that. Now connect the loads. Right, so you can on this load 1. So it is showing the load 1 is the low and load 2 is no load, as we are not owning the second load. Right, now the load 2 is low and load 1 is the low. Now just switch off this and then only remove that, because if you remove directly due to any power fluctuations, the system provides us the restarts signals to the Raspberry Pi. Now we are going to use 60 watts one and 100 watts next. So it is going to be the medium one and another is the high. So just we switch on this 60 watts bulb. So it's going to be the medium reading displaying on the LCD screen. And next, if you on the second load 2, it's going to be the high signal. So medium and high. So now the load 1 is going to be the high signal will be displayed over here. Right. And load 2 is a medium signal. right, as the processing will be delayed sometimes, right. Now again no load will be displayed here, and now just we will connect this high load to the and low load to this one. That's going to be the low load now, load 1, and load 2 is the high load. So it's a continuous process by the system to predict and to estimate the load levels directly by using the Raspberry Pi. You can see once again placing any load over here and low load to this. So medium load, as we have connected the 60 watts of bulb over here, right, and no load previously, it's a low load now. Thank you.